Hey everyone, today we are going to be talking about using the greatest common factor to factor numerical expressions and algebraic expressions. So basically we're going to be doing the distributive property in reverse. So we're going to start by doing it with just numbers, and then we're going to look at numbers and variables. So you can see that in each example I have a little box, a little starburst here for the greatest common factor. So when we are doing each of these questions, the first thing that we're going to do is we're going to identify the greatest common factor. We're going to put it in that little bubble. And then we're going to use that greatest common factor to help us factor the expression. So when I'm looking at 45 and 72, 45 and 72 both have a 9 in common as their greatest common factor. Because 9 times 5 is 45 and 9 times 8 is 72, and that is the biggest thing they both have in common. So the first thing that I'm going to do is I'm going to write my multiplication with 9 as my first factor. Okay, so 9 is the greatest common factor between 45 and 72. So I'm going to write each term, so 45 and 72, as factors with 9 first. And I've already said that 9 times 5 is 45, and 9 times 8 is 72. Okay. So again, this number needs to be the same. Okay. And then the second number is what multiplies to make the numbers in my answer. So 9 times 5 makes 45, and 9 times 8 makes 72. Then we're going to write our expression with the two inside numbers in the parentheses, and then my common factor on the outside. So my common factor is 9, and my two values on the inside are 5 and 8. So today we're starting with the answer from yesterday and working our way back to the question. Okay. For 80 and 56, so I'm going to list out some factors here. You can use your multiplication chart. Some of you may know the greatest common factor between 80 and 56. I'm going to list out some factors here. So for 80, it's 1 times 80, 2 times 20, 2 times 40, 4 times 20, 5 times 16, 6, 7, 8 times 10, and then 56, it's going to be 1 and 56, 2 and 28, 4 and 14, 7 and 8. So I can see that they have an 8 in common. So that's what I'm going to use as my greatest common factor. So that's going to go in my little starburst. Now, once I've got that, I want to put that 8 first in each set of parentheses. And then I want to figure out 8 times what number gets me to 80. 8 times what number gets me to 56? Well, 8 times 10 gets me to 80. And 8 times 7 gets me to 56. So now I need to write my mostly factored expression with the 8 on the outside of the parentheses, and then the 10 plus 7 inside the parentheses. Okay, in number 3, I've got 42 and 28. So again, I'm going to look at some factors here. So 42 is 1 and 42, 2 and 21, 3 and 14, and then 6 and 7. For 28, I've got 1 and 28, 2 and 14, and then 4 and 7. Here I can see that they have a 14 in common as the greatest common factor. They have other common factors, but we want the greatest common factor, the biggest one they have in common. So many of us are going to choose 7 first. That's not the greatest common factor. That is just a common factor. 14 is the greatest common factor. So I'm going to have 14 listed for both of these. And then I'm going to go, okay, what times 14 gets me to 42? Well, I can see in my list of factors here that 14 times 3 gets me to 42. And that for 28, 14 times 2 gets me to 42. Those both can be found in your multiplication chart. Okay, so you're aware. And then we're going to take that 14 and we're going to put it on the outside. And we're going to take the 3 and the 2 and put it on the inside. Okay, number 4 here. Just setting up my work here. For number 4, I've got 15 and 18. So 15 is 1 times 15 and 3 times 5. 18 is 1 times 18, 2 times 9, and 3 times 6. And I can see that 3 is the greatest thing they have in common. So 3 is going to go in my little starburst over here. And then 3 is going to be in both of my sets of multiplication. 3 times 5 is 15, and 3 times 6 is 18. So 3 goes on the outside, and then 5 plus 6 goes on the inside. This is numerical expressions, so just numbers. In a second here, we're going to look at numbers and variables. Okay, so in example 2, it says use the greatest common factor to factor algebraic expressions. So now we're going to have a greatest common factor, but this time one of our factors is going to have a variable that's left over. So when I look at 3x and 6, they have a 3 in common. So these are relatively small numbers on this first one. They have a 3 in common. So in my first set of work, I'm going to have a 3 that comes first in each one. Now I'm going to say what times 3 gets me 3x? Well, 3 times x gets me 3x. And then 3 times 2 gets me 6. Okay, same thing applies for this one. So the 3 goes on the outside of the parentheses, and then x plus 2 is inside the parentheses. In number 2, 36 and 30 have a 6 as the greatest common factor, I think. Let's double check. So 36 is 1, 2, 3, 4, and 6. Yep, 6 is going to be our greatest common factor. So 1, 2, 3, 5, and 6. So yeah, 6 is going to be our GCF here. So in my first step here, when I break it down, I'm going to have a 6 and a 6. Now for this one, I'm going to have a number with my variable. So 6 times 6 is 36, and then I also have an x, and then 6 times 5 is 30. So I'm going to have a 6 on the outside, and then a 6x plus 5 on the inside. 21 and 35 have a 7 in common. So my greatest common factor is a 7. So when I set up my initial multiplication, I'm going to have a 7 in each spot. And then 7 times 3 is 21, and then I have to include the x, and 7 times 5 is 35. So then I have 7 on the outside and 3x plus 5 on the inside. My last one, between 8 and 4, they have a greatest common factor of 4. So when I write my initial multiplication, I'm going to have a 4, then a 4. 4 times 2 is 8, and then I have to keep the x. And 4 times 1 makes 4. So when I write my distributive property, it's going to be 4 on the outside, and then 2x plus 1 on the inside. Okay, this is factoring expressions by greatest common factor. We are starting with essentially the answer from yesterday, and then working our way back to the question. There is a worksheet of practice on factoring, and we will go over answers tomorrow.